Hello and welcome to Embedded ARM Dev. This is the second of two videos where I'll show you how to cross-compile a third-party library for your target system. In the first video, I gave some background knowledge for the general process of configuring, building, and installing software. So if you haven't watched the first video yet, I encourage you to check it out. I'll make sure to put a link to it in the description. In this video, I'll give you a practical demonstration by cross-compiling two third-party libraries, zlib and OpenSSL. Zlib is a free compression library. OpenSSL is an SSL, TLS, and encryption toolkit. I'm not going to go over how to use these libraries. I'm just going to use them as examples for illustrating the build process for cross-compiling libraries. The reason I chose zlib and OpenSSL is that OpenSSL can be compiled to include compression using zlib, which will be a great way to demonstrate how to build a library that links into another library. So we'll build zlib first, and then when we build OpenSSL, we'll configure it to link into zlib. So let's get started. So here we are on an Ubuntu Linux. This is on VirtualBox. And so the first thing I did is I just created a projects directory. It's for a place that we can hold our work. The first thing that you want to do is make sure that you have the tools installed that we're going to use in this video. So if you haven't already, so you want to install gcc make, and then we're going to install this is the cross compiler. Okay, so we'll go ahead and use this one here. Now I've already got these installed, so just make sure that you install these before you continue, so that if you want to follow along. The first thing we're going to do is I'm going to make a directory that will hold our installed files. Okay, so this is going to be the directory where it'll eventually be the root file system for our embedded device, or it might just be the cross-compile embedded development environment directory. Anyway, this is where all the target files are going to go. So we'll go ahead and make that. So we list it. Okay. So first we're going to do zlib. So I'm just going to make a directory for zlib. Okay. So the first thing we need to do is just get zlib. So we'll open up a web browser here, and I'm just going to do okay. All right, so this is the zlib. This is how you can get it. Come down here. All right, this is going to be the source code right here. So we'll just get 1.2.11. I mean, that's the only version that's on here. What I do is I go ahead and copy link location, because I'm going to use wget. Okay, so I'll use wget, and so now that I've got that copied, I'll just type wget and then hit paste, and so that will pull this tar.gz down. Okay, so there it is. So now we will use tar to extract it. So we'll take tar, and we'll give the options .xfs to extract the file, and then we'll specify the file we just downloaded, and it will create a directory right there. So we'll cd into that. So I did a list to show, to give you an idea of what we're looking at here. First thing to note is here's the configuration script. It's a shell script. Okay, there's no other ones that I can see, so this is the one that we're going to run. The first thing you want to look for is a README file. You always want to read the README file. And then another one that I would look for, which is not always present, is a file called install. It could be install or install info or something like that. This one doesn't have one. zlib's a pretty simple one to build. But if you want, we'll use gedit just to take a look at it. So this just talks about what it is, and so to compile files and run the test program, follow instructions given at the top of the makefile. So here we see that there's instructions at the top of makefile.in. So if we wanted to, we could go look at that. And in short, so these instructions here tell you make test, and if that goes well, make install. Okay. So anyway, I'm going to show you the steps that I'm going to use. This gives you some information that you might want to read through, usually things that are specific to each version. Okay. So for zlib, this one, it doesn't have a lot of information useful to us for our purposes today. So I'm just going to head and close it out. So another thing that we can do that can help us is to run the configure command with the help option. And so that gives us an idea of what it's looking for. Unfortunately, this one isn't very verbose, but once you get used to cross-compiling libraries, you will understand what a lot of these mean. The important ones are, let me find it here, this one. Okay, so this basically would be the path where you want this stuff installed when you actually run the install. Okay, so keep in mind it is relative to if you pass in an install directory, which we're going to do. So in this case, it would be our root file system. This prefix here would be relative to that directory that we specify. So it just depends on where you want to install it, but this is how you are going to set it up. Libdir would be where it installs the lib files, okay, which are going to be the shared objects themselves. And again, that is relative to this prefix, okay? So the default directory is going to be /lib, relative, right? Not directly off the root, but relative to the prefix. So if you're fine with it going in there, then you can just leave this one out. So those are a couple important ones. And so we're just going to set this up. So we're actually going to go. The one thing that we need to do, this is a good example, is we're actually to specify the cross compiler for this particular one. We need to pass it in as an environment variable. So we'll just type cc equals. So in this case, we're actually passing an environment variable, so we do want this GCC at the end because we're telling it that's what the compiler is. That's the first thing we're going to specify. Okay, and the next thing we're going to specify is the actual prefix. Okay, so I'm going to say prefix. So the problem is with this one, and I just learned this by trial and error, is you have to specify an absolute path. You can't just say, you can't use like, it can't be relative to where you are or anything like that. So we need to do an actual absolute path. And so what I'm going to do is just pull up another one. And so we want it to be here, right? So this will be the absolute path. And then I'm going to put it in user/local. Okay, again, this is what we specify, and that's actually probably going to be the default. If you didn't specify this, then that is where you would install it. Okay, so this is the actual install path directory. This is where it's going to install it. If we did not add this prefix in here, then it would try installing it on our host system, and we'd have a bunch of ARM binaries hanging out on our host system. And so for this particular one, that's it. That's all we need. So go ahead and hit enter. So this is just going to configure it. Okay, so we have a good example here. When we tried this, we see that when I passed cc in as a command line argument, the configure file, the configuration script didn't like it. So we actually need to redo this and pass it in as an environment variable that gets exported to the configure command. And so all we have to do is take this. Again, this is something I learned through trial and error. This may or may not work. Okay, so we're specifying the cross compiler, we're calling configure, and we're passing an option prefix. And the prefix specifies exactly where we want the install directory to go. So let's hit enter and see if it works. Okay, there we go. Note here that it says we're using the ARM Linux GNU IDBA GCC, which is what we want. We hit ls. So there's a configure log here. Okay, so this will tell us some important information. So it's set up so that CC is this right here. Okay, so the prefix, which is, here it is. Okay, it was down here. And so this is where it's going to install everything. And so the libdir will be this directory plus lib, and the include dir will be this directory plus include. So once we install it, we should have those two directories, and we'll see that. Okay, so now that we've done that, we've got the configuration set up. All we need to do is make. All right, so we're good. So now if I come over here to the root file system, you see that it's still empty. We didn't actually install anything, right? So everything is inside this directory over here. These are all the .c.o files and everything. So all of the object files are actually right here. And so you can see here that this one right here, this is the actual shared object, which is what this is one of the target files. Okay, these three right here, well, those three right there are actually target files, but we're going to look at them when we get into root file system. So all we have to do now is do make. Okay, so what this is going to do is it's going to move all the files, all the relevant files over to our prefix directory that we specified, which is inside the root fs. And so you'll notice that user local doesn't exist, and that's fine. But make install will actually create them if they don't exist. Okay, so we'll go ahead and run this. And you can see here that it looked like it copied everything correctly. Okay, this is where we want it. So you got user, so we got an include, a lib, and a share. So if I do, you can see that there's some header files there. If I do lib, okay, you can see this is the shared, this is the actual shared library, and these are just symbolic links that point to it. And then if you're curious what's in the share, it is the documentation, and there's a lot of it. So one thing to consider is when you actually end up putting this on your embedded device, if you're not going to need the man pages on your embedded device, you may not want to copy this entire directory over, right? You may only want, these particular things. And also, you may not want this .a, which is a static archive. You have to be smart about what you want to actually move over to the target embedded device, because you don't want stuff on it that you don't need. So I would consider this more of a development environment, this directory that we're doing. So we are done with zlib. That was really easy. So now I'm going to make a directory. I'm going to call it SSL. All right, so now I'm going to go back to the directory, or excuse me, the web browser. Do a search for OpenSSL. Okay, go to it. So go to downloads. All right, so you'll notice here there's a 3.0 and then a 1.1.1i. So you right here you want to note that 3.0 is the next major version and is currently in development. Okay, so we're going to actually just use this one. We're going to use 1.1.1. So I'm just going to copy the link. Okay, so now I'm in my SSL directory. I'm going to wget that. All right, so we got that. So again, we'll just tar. Okay, so for this one, notice that there is a README, but there's also an install file here. So we can take a look at the README real quick. So it gives you an idea of what's in it and how to contact people for, if you have any issues or how to submit bugs and stuff like that, okay? So this probably isn't what we're looking for. Okay, so here it says installation, see the appropriate file, install, and then any notes, okay? So we're actually interested in the install file. So this one we're actually going to spend some time looking at because it's a pretty good example of what you'll find when you're trying to build other libraries. So the first one we're going to look at, so here it just gives you like, if you just want to get going, you'll do /config, make test, and make install. We're going to do a variation of this. The thing with make test is it'll actually try to compile some really simple C files using your compiler, and then it tries to execute them. Since we're using a cross compiler, this test will usually fail. Okay, I think every time I've tried it using a cross compiler, it always fails, saying that it can't execute the program. That's because it's trying to execute an ARM binary, which on your host isn't going to work. So unfortunately, when you're cross compiling, you just have to put some faith in the developers and just hope that everything works, because we generally cannot do this particular step. So another thing is, let's go down here and see if there's any other useful. Okay, so here you look under configuration options. This is really important. You want to look at these so you know what options are available for this particular library, because it's going to vary. Every single library you download and try to install is not going to have all the same things. There's some common ones, but they're not always the same. So the first one that I want to point out is the cross-compile prefix. So this is an option that allows you to specify the prefix of the cross-compiler. And so it would be everything except the except the GCC. So here they got this MIPS one as an example. Another thing and we'll go into it more later, but we're actually going to use this script here because through trial and error, I've determined that some of the options that we're going to pass in, if you pass it into .config, it doesn't know what they are. It gets confused and says, I don't know what those are. So we actually use .configure. And if you read these, you'll note that this .config, what it does is it determines what system it's running on, and then after that, it calls this script right here. So we're just going to call this one right here. Okay. So the first thing we're going to do to build this out is do this. And so for this one, it's going to be, that's what we're going to have. So now if you use the backward slash, it allows you to continue on the next line. So we're going to go ahead and do that so that it doesn't get garbled and hard to look at. So, all right. So the first thing we specified was the cross-compile prefix. Okay. So this is another one that we're going to specify. Okay. So what this one is it's a directory that holds your OpenSSL configuration file. So we're going to go ahead and just give that a file name. This is the default, right? And so we have to actually. We do need to give it this directory here, okay? So I'm going to print working directory because what we're trying to do is tell it where we want to install these particular files, okay? And then from there, I'm going to go with their default. So now if we didn't specify this, then it would try to install this on our host computer in user local SSL, and we don't want that. Here's the really, really important one, okay? Prefix equals .dir. So if you see here, the default is to do it off of /user/local, which this would install it on your host computer. And again, we don't want that, okay? Okay, home dev projects root.fs user local. So now it's going to install. So this is the top, the installation directory tree. And this is where it'll install everything. Now, we see here that we've got these right here. This is, since we want to build this with zlib, we're going to have to specify these. So this is the directory for the location of zlib include files, and then this is the directory containing the zlib library. So we will have to specify both of these. For this one, we'll just copy this because we're going to use it again. So from the local directory, so we're here right now, and we notice that zlib is installed, and for this is the zlib include, so we want the include directory, right? Those are the header files we want. So all we're going to do is finish this off with include, and that's it. So that now we're specifying the zlib include equals, and we're telling it where it is. So this is a good example of where the configuration script will have an option, an actual option that you can pass in specifying where a library is. Sometimes if this didn't exist, we'd have to specify using one of the variables, one of the environment variables. So if you see this, then definitely use this method rather than trying to specify the environment variable, because this is probably a better guarantee that you'll get what you want. So this is the next option that we're going to specify. Okay, with zlib library equals, and then we're telling it where the .so files are. Okay, so the preprocessor, I should say, is going to need the include, and then the linker is going to need to know where the libraries are. So we keep going. So these are all these options. If you want to look into them, we are not going to do it. There's like a ton of options that you can look into, but I'm looking for one specific. Here you have two options. So now we want to, not only, we've specified where the include and lib directories are, but now we need to tell the configure script, hey, actually build with zlib. So what would happen is if we could pass these in there and then not call one of these, and it wouldn't do anything. It would use these for nothing. But if we passed in one of these and we didn't specify these, it would throw an error saying, hey, I don't know where the include file is. I don't know where the lib file is. I don't know where it is. And so it would complain. Okay. So looking at these two options, if you just use this one, then it'll build support for the zlib compression, but probably all of that will be statically compiled into your OpenSSL, which you may or may not want. and that's going to depend on what your embedded target is going to look like. I would say that if you're going to have the zlib, if you're going to have this, right here on your target system, then just go ahead and build it dynamically, because it'll link into that shared object. But if you plan, if maybe this is the only one that's going to use your libz and you don't want to have this on your target system, that's fine. Just use zlib. Okay, so I'm going to actually go ahead and just do dynamic. Okay, so here's a good example of, so you see var equals value. So these are good examples of variables that you could pass in as command line arguments. So they would come in after the /configure command. Then you could specify these. You could specify any of these if you wanted. Okay, it just so happens we don't really need to. In this example, if we didn't have these with zlib include and with zlib lib, we would have to use this for the include, and we'd have to use this to specify the lib directory. But since this script came with these options, we don't need to specify these. So you may run into situations where you have to use these variables to specify these directories. Okay, so just keep that in mind. All right. So the one thing that is probably at the very top that I needed to point out. Okay, so this took me a few minutes to find it, but through trial and error I learned that with OpenSSL, you need to specify your operating system manually. Later on in the video, I'll try to find where I found this, but you're basically going to give it a tuple that's going to specify the target for the binary. And the target's going to be your embedded device. So in this case, it's going to be ARM. And so in this case, we're going to use Linux ARM version 4. I will show you later in the video how I determine that, but for now, we'll just leave it in there. All right, so I'm going to go ahead and enter and see if this works. So it looks like it was successfully configured, and we can see that we have, for our directories, we can see that it looks like it's pointing to the correct location. So now what we're going to do is just run the make command. So I suspected this might be an issue. When I ran the command, the zlib dynamic shouldn't have these two hyphens. So that was, it wasn't an option. It was a command line argument that's not an option. Okay, so we should reconfigure it, and then we'll try running make again and see if that works. Okay, so mine is finished. If you go ahead and pause the video and wait for you to finish, it should take less than 5 minutes depending on what type of system you have. One thing I want to do is just copy this. We'll put it in a notepad here so that we can look at it. Okay, so this is just a review of the command that we use. So this, you can see all the heavy work is done in the configure script. We specified the cross-compile prefix. This is a directory that is just where the SSL configuration stuff is located. This is the really important one because this tells the top install directory, so everything's going to be installed to user local. This specifies the include and lib directories for zlib. This says, hey, go ahead and compile zlib in dynamically, and then this specifies the target tuple for where we're actually going to, for the target device, the embedded device itself. All right. So now we built everything, and if we see here, we got a couple of shared objects right here at the top. So I'm actually just going to do call file on this one. Okay, this is a good habit to get into, just checking to make sure that everything compiled properly. I didn't actually do it on the first run, but okay, you want to do this to make sure that it's actually getting compiled to, your target. So ARM, 32-bit, LSB, so it's little endian. So this tells you that, hey, this was indeed compiled for ARM. Okay, if this said like x86 or something, then we messed something up somewhere. All right. So if you come back over here, there's no bin directory, and you notice that in include and lib, nothing's changed, right? Because we haven't done make install. So now we'll just do make install. Okay, and we'll run this, and it should just install everything. So you can see there's a lot of man pages. So again, when you're trying to move this over to your target device, you may not want to have all these man pages in there because it probably takes up a lot of memory. So it just depends on what you're running. You know, more than likely, you're not going to need those man pages on your target device. Okay, so the install is finished. So go ahead and pause the video until yours is done. Okay, so now that your install is done, we can go ahead and do a list. And now we see that there's a bin there. There's the SSL directory. There's the shared directory, which was there before. But so if I do ls bin, now you see that we've got two. These are actual binaries, okay? So you would actually run OpenSSL to do whatever you need to do, whatever OpenSSL functionality gives you. So this is an executable binary. So this is a executable. It's ARM, all right, dynamically linked. So that's another thing. I believe I pointed this out in a previous video that I made about shared libraries. This file is going to look for this linker on the target system, on your embedded system. So this will actually be somewhere on your development environment, wherever the ARM Linux GNU EABI/GCC is, somewhere in that general vicinity of that actual, where that actual binary exists. You're going to have these shared objects. Okay, so those will need to get pulled over to your target device. Otherwise, when you run them on your target device, it's going to look for this file and it's going to fail because it won't find this file. Okay, but I did cover that in another video. So there we go. So when we look at lib, we can see now that we've got libSSL, and then we've got libcrypto. Okay, so in this particular, development environment or root file system, we've got three shared objects that we can tap into. Okay, and as promised, I wanted to show you where I got this tuple right here. So this is the command that we ran to configure it, to configure OpenSSL. So I'm actually just going to delete that tuple, and then I run it, and it's going to complain saying that I need to specify pick os/compiler from, and so here's the list that you would have to choose from. Okay, so this tells you what all your things are. So you might be able to use Linux Elf. I've never tried it. That might actually just try to do an x86. Play around with it. Let me know in the comments what if it works for you. I've never played around with this because when I looked through here, I saw the ARM, and I was like, well, that's probably the only one that really is what I want, and so I used that one. You could try using one of these or maybe one of these and see if it would let you do it and everything would work properly. I suspect this actually has to do more with the ABI than the actual architecture. So I'd be curious if that would work. Okay, and one last thing that I want to show. I don't want to make this video too much longer, but so what I'm going to do is remove this directory. Okay, so this has all of our configuration information, right? Okay, and then I'll just re-extract it. What I want to show you is that you do not have to do all of your configuration and building inside this directory. Okay, you can do it in any directory you want. So what I'm going to do is I'm going to make another one, and I'm going to call it SSL with compression. Or actually, I'll call it zlib. And so now what I'm going to do is cd into that. Okay, and then I'm going to go ahead and just go up until I find that command that I used. Okay, don't want to forget that. But we're going to go up here, and instead of, we're just going to say, hey, it's in the parent directory, and it's in OpenSSL. So I'm going to give a space here. Okay, so this directory right here, we're going to go up one and into this directory and then call the configure command. So what's going to happen is it's going to call this script, this shell script, pass in all of these things, but it's going to build it right here inside this directory. So we're not trashing this directory with a bunch of build stuff. We're doing it inside this directory. Okay. And so this is useful if you want to create two separate build environments. So let's say you want one where you have a build environment and then you make another one with no zlib. And so then we'll go, all right, so it's empty, right? So we'll just do this, but we're gonna get rid of anything that has to do with zlib, okay? And so everything else needs to stay. And in this case, so we're gonna configure it. And now we have two separate build environments. We got one with no zlib and one with zlib. And so if I build these targets, if I just go inside each directory and I execute the make command, then it'll build it and all of the build files will still be in here. And you have two separate environments. The thing to be careful of is when we gave it this prefix right here, in both commands I gave it the same prefix. So what would happen is if I ran one and then if I ran make install, let's say I run no zlib and I do make install, it'll install all of the files that don't have any zlib decompression with it. But then I switch to this directory and I run make install, then it'll overwrite everything because we specified the same directory. So if you do want to keep them truly separate, then this prefix should also be separate. I wanted to point that out. That's a general option for running for this, all of these. Whenever you build, whenever you call the configure script, it doesn't have to, you don't have to be inside the directory that configure is. Okay, you can make a separate directory that you want to build everything in, and then you call the configure script from that directory. So it's a nice way to keep all your build environments different, separated if you're trying to do different configurations and play around with different things. And that way, once you built them, once you run them with make, you don't have to build them again, right? You can just go in there and do make install, and it'll just install it to where it needs to go. All right, so let's summarize what we did in this video. For zlib, we passed in the cross compiler as an environment variable to the configure script. And then we used the prefix option to specify the installation directory. Then we simply called make to build the library, and then we call make install to install the target files to the specified directory. For OpenSSL, it was a little bit more complicated. In this example, we used the cross-compile prefix option to specify the prefix of the cross-compiler, and then we specified the installation directory using the prefix option, and then we used the OpenSSL dir option to specify the location of SSL configuration files, and then we used with zlib lib and with zlib include to specify the locations of the library files, which are the shared object files, and the include files, which are the header files for the zlib library that we built earlier. Then we specified that we wanted to build it dynamically with zlib, and then we specified the operating system and architecture tuple. Then we simply call make to build the library, and then we call make install to install the library to the target folder. And that's it for this video. I hope you found it useful. If you have questions or comments, please leave them in the comments below, and I'll see you in the next video.